Hello.
So what's the topic for today?
Today I want to talk about weak references. So let me first explain what it is. I'll do that in JavaScript. Okay, I'll first create an object. Right. So here is an object. And then I'll create a map. And I'll use this object as a key in the map. Mm-hmm. So that's a little bit in, if you have objects like this one, the keys are always strings, really. Mm. If they're not strings, they'll be converted to strings. But in maps, you can use objects also as keys. Mm. So now I'll use that object as a key and set the value of that key to hello. Mm. So now if I go, now I'll get the value from the map. Mm. And I can look at the map here, and it says like, yeah, that this object is now the key pointing to the value, right? That's still there. That's still the same. The variable o is also pointing out to the same object. But if I do like this, now the variable o is no longer pointing to this object. Yeah. But if I look at the map, the object, this value there, that's what I set up here. Mm-hmm. So that's still alive, right? Mm-hmm. That's a normal map. Mm. But now I'm going to create a map with a weak reference. So this is a strong reference. Mm-hmm. What makes it strong is that even if we change the value of this variable, mm-hmm. Now this is the only place in the program or in the memory where this object exists. Mm-hmm. Yeah. So now I'll do the same thing, but I'm going to use a weak map instead. So create an object, and then I can do now get, and that works. Well, it's interesting to look at M. Now it doesn't tell us what's in there, mm-hmm. but now if I do that, now the reference here to this variable that I was set up here, it's now gone. Because with a weak reference, it works like that if there's only one reference, mm-hmm. it gets automatically removed.
Okay, can we see if it's gone?
We can't see if it's gone, because that's kind of up to the system and up to the garbage collector. Oh. Right? And since we don't have any more reference to it, like what we did up here, we can no longer do that, because we have kind of removed our we have removed every reference that we had to it. Mm-hmm. The only reference that could potentially exist is the reference inside of here, but that gets removed automatically. What's the point of having a reference that disappears like that? Yeah, if you can't get to it, why store something in such a way so that you can't get hold of something, or something like that? Mm-hmm. But that is a weak reference. Right. And when I wanted to try to understand why this exists, well, I've been programming a little bit C and also Rust in the past, and Rust is not, and C, they're not garbage collected languages. And in that case, you have you can have like then they are reference counted, so they count the references instead of the way that they keep track of which objects that can be cleaned up or not cleaned up, or you have to basically do it yourself in C. But the way that I often do is with reference counting. So if you have one object here, you have maybe one reference to that object, but then you create some other object and you have a reference from this object to that object, and a reference from that object back to itself. And this can be useful, like if you have, say, maybe this is a window and this is a button inside of the window, and the button needs to know like the context where it exists, so it needs to have a reference back to its parent. Right? Yeah. So that's quite common. So then you would count the references, and here there are two references. This object here has two references to it. This object here has one reference to it. And the way that it works, well, normally, if it would just be this, that would be one reference. If you remove this reference, there are zero references, and then you know that you can deallocate or remove that memory. Yeah. But in this case, when they point to each other, and this is 2, and you remove this, then there is still 1 here. Well, there's one there, so there's nothing you can remove because they still have references. But there's nothing from the outside that points to this. So yeah, that would be a good candidate for cleaning up. But if we have strong references, we won't be able to do that. Right? So therefore, we can use instead a weak reference. That makes sense, right?
Yes.
That makes perfect sense to me. And I think that this weak map was introduced in JavaScript 6 or 2015. I'm not sure. But I was very surprised to say that it was included because I couldn't understand. JavaScript is a garbage collected language. So why on earth would you want to have a weak reference in a garbage collected language? That's the question.
So, did you find out why they have it?
Well, yeah, I found a use case a couple of weeks ago when I was experimenting with Cloudflare workers. There was a really good use case actually, and I went like, aha, now I see. That's why it exists. So I would like to try to recreate that environment where I found it. Right? I'm gonna set up a Cloudflare worker here. So I'll do that with Wrangler. Alright, so here's my worker now. This function gets called on each request. Okay, now I have a worker here. Yeah. And what I want to do also is I want to have a database for my worker. So I'll do that too. I'm going to follow, I want a database and I want an ORM, which is called an ORM called Drizzle. And I want to use it for Cloudflare, and there is an example. So I'm basically following this example. I'm going to remove all of this, just have the database here. Okay, now I need to create some data in my database too. I can do that. I create a table. Posts, I'll call it. With an ID and okay, now I have a database with a little bit of data in it. And since I want to use drizzle, I need to also add that as an npm. Oh, here's my little program. So drizzle as an ORM, it needs a definition of the database, and then I create an instance of drizzle here, and then I get my posts with a select query from my table. And let's see if that works. Well, it didn't crash, but I guess I need to add them here too. Ah, okay. That was just boilerplate, just to set up a little database. Right, but we can see what the code is doing here. Yeah, first it creates this table, then it creates a drizzle, a database, a database abstraction for the database, which comes in the environment variable here. And then it gets all the information from that table and just sends it out in the response. Right. So that's pretty easy. But yeah, now it was about weak references. This video. So what is interesting here is that this information here and this information here, it's being created on every request. And this is the database. That's something, it's the definition for the database. Right. So that is probably something that's not going to change throughout the program. So here is probably pretty, it's not doing very much, but probably if it was doing more, maybe it would need to have the information, maybe it comes from some XML file or something that needs to be parsed. I mean, this can be, yeah. I think I would want this to run on as an initialization rather than to run on each request. So what could I do then? I could take this and put it here maybe. Do you see any problem with that? Well, it's interesting here to say I get this variable, the environment.
Oh yeah.
It's coming in as part of the request. Yeah. So I don't have any access to that up here. So that's also interesting with Cloudflare, because Cloudflare is like subtly different from, for example, Node.js. In Node.js, normally you would probably have this in some configuration file, and you would read the configuration file, and you would set things up and stuff. You are more in Node.js. You are more free to do what you want. Right? In Cloudflare, you're part of a more controlled environment, which is actually a good thing, because then that's what enables this infinite scalability and everything. That's so awesome with Cloudflare. But in this case, it's a problem, right? So how do we solve this now? And here, this is where we can now use a weak reference. Because also, we want this, we can use on Cloudflare, we can use the same worker for several different environments. And also, I don't know really how this environment, how it gets created. If it gets created several times, if it like maybe disappears and then gets created again, if it maybe disappears when my worker goes to sleep and then it wakes up again.
You don't know that.
I don't know that. And if I think a little bit about it, I think that it doesn't. But the thing is that it could. It would be nice to be able to make our program here resilient, right? So that it actually can run on spread out over hundreds of workers all around the world, that sort of comes and goes and does stuff like that. Right? So this is now where weak references come in handy, because yeah, I want to associate some information with this environment. But if the environment goes away, I no longer want to have that association. So that if we say that this is, let's assume that it's something like this, that probably the environment will not be created on every request, but maybe say on every 10th request. Maybe each instance of the environment gets to handle 10 requests, and then it goes away, and then it's a new environment, and that gets to handle 10 requests. So I don't want to, and then maybe that keeps happening and happening and happening. And I don't want to have the environment, like my associated information with the environment, I don't want that to leak. And if it was a strong reference, yeah, that would be memory leak. Then that would leak some memory or some resources.
Okay.
Right.
So how are you gonna do that?
So let's just simply try to do this now with a weak reference. So then we can have the actual map here global. And then we check in here if we have any information associated with this environment, or I should say if we don't have any information. Yeah, so now we can store that in an object that's associated with the environment inside of the weak map. So we have that post and that, and then after this, so this code should then just run once for each environment. But this code here, we can assume that we have this information. We can actually get it like this, and then get it through okay, let's check if it still works. Oh, it does. It does. Let's put now here a console log. Oh, it's creating the database environment. Oh, and then we can see that. So it reloaded the server, then it creates the database environment. But if I now reload that several times,
It doesn't happen again.
It doesn't happen again. But if this would somewhere go away from inside of Cloudflare, which apparently it doesn't. We can see that it doesn't. It kept itself alive here, but it could have gone away, and we have made our program be like resilient if it would go away. Or it could be the case maybe on Cloudflare it doesn't go away, right? But we have made our program resilient to that environment, so that environment could potentially go away.
Yeah.
So that's where it suddenly became useful with the weak map, even in JavaScript, which is a garbage collected language.
Oh, that's cool. So at the moment, people do it without the weak references because Cloudflare has been reliable, not to fail, or what?
I don't know. No, like the example here, the example for Drizzle.
Yeah.
They actually do it on every request.
So there's like an assumption that it will never fail. The environment variable will not be reset.
No,
No?
No, the way that they do it, they assume that it will never be there, so they always create it every time. And they can probably do that because probably this is something very lightweight. Well, I don't know. It's not mine. I didn't make it. But probably, since they do it that way, like this, whatever object it's getting returned here is probably quite lightweight, and it's probably quick to create it. Right? But that might not always be the case.
Okay.
Yeah. So they don't assume that it doesn't go away. They assume that it always goes away.
And the solution is to create a new one on each request.
Exactly. Yeah.
Cool. That's it for today, I guess.
Okay. Bye bye.
Bye.